Assalamu alaikum. My name is Abdullah Ajmal and today I will be explaining lab number 2 of microcontrollers and embedded system. So basically what is lab number 2? In lab number 2 we are going through introduction of assembly programming of AVR microcontrollers. What are the objectives of this lab? The objectives of this lab are that we will become able to understand code in assembly language and how they work. We will use command in assembly breaks and implement tasks according to them and perform their Proteus simulation in Proteus respectively. So basically the component that we need require Arduino, LED jumper wires, and for the software part we require Atmel and Proteus. So basically, what is assembling language? So assembling language is a low-level programming language designed for specific type of processes. It may be used as a basic for all other compiling sources. So basically, whenever we write a program, even if it is in C language or any other language, first of all, it is converted into assembly language, and then the computer can understand from this assembly language into binary language that what we want the computer to do. So these are the basic command of moving data from one register to another. This is the add command which will add data of two register and save it into the first register. Then we have push command, pop command. These commands are used for when we are using stack in assembly language. Then we have jump command that is used to jump from one place to another place, described by the name written forward of jump command. Then we have int, that is interrupt processes. So it has both advantages and disadvantages. Advantages that the it is faster, and major disadvantages that different type of controllers need different type of assembly language, and further the difference is the syntax that is very difficult to remember. So basically in assembly language we are working on base level, so we have to define every port, every pin accordingly for input and output, then perform function according to it, and then give respective output. So basically for the ports we have first the direction set register DDR, then we have port register to show output, and we have pin register to take inputs. These are the basic commands that we can use in assembly language LDIE. So basically these are the commands. So this is lab assessments. These are basic instructions that we have to run on our Atmel Studio. So basically what is happening in this command is that we are loading value in register 16 and then declaring our register DDRB as output, and we are running it in a loop, then displaying this value on output. So in second code we are loading R16 into 0x25 into R16, 0x34 into R17, then adding both R16 and R17 and result will be into R17. Then we are storing the value of R16 to 0x23 memory space. Then we are loading the value of 0x230 memory space into R0, and then we are loading the content of the 0x20 in R1. Then we are again adding them and then returning the command. Then we have code number 3. In code number 3 basically we are directly giving decimal value of 10 to R17, 0 to R18, 4 to R19, and then we have a label for again. Then we are again and again adding the values into each other, and then finally displaying the result on port B. So this is first task: store R13 30 in R16 and binary and display it on any port. After then add 25 in that value and result on any port. Clear R16, show the simulation in Atmos Studio. So basically the code written is that R16 will get the value of 30 and R18 will get the one will get the value of 30 and one will get the value of 25. So basically we will run the code and then add the booked values and display the answer, and then show it on Atmos Studio. So basically this is the code. So now let's move towards the Proteus simulation. So this is the Proteus simulation of task 1. So let me show the AVR Studio code. So task 1, this will be the AVR Studio code. So this is the code written in AVR Studio. You can see all the commands and they are well commented. So let us move towards the Proteus simulation. First of all, we'll go and add our file in edit properties, and then we'll add our files. And so as we can see, first of all, it is displaying the value of 0x30, and then it is adding 25, and then finally displaying the added value on the other port. So stop the simulation and now close this task one. So now we will move towards close this admin task as well. Now we will move towards the task number 2. So basically what we are doing in task number 2 is take input from one port and display it onto another port and simulate it on Atmel Studio as well. So basically what we will have, will declare a register as empty, then we'll declare one port as output and one port as input, then we will get that value from our input port and then store into register and display that register out on the output port. So now let us move towards the task 2. So this is the Proteus of task 2, and now let us move towards the Atmel of task 2. This will be the Atmel of task 2. So this is the Atmel of task 2. So basically what we are doing, declaring a register and then declaring a port as output, declaring a port as input, and then passing on, storing the value in our register and then displaying the register on port B. So let us move towards the Proteus, go and upload hex file. So now let us give the values supposedly, really this value 1 1. As we can see, it is given as 0 0 0 0 and 1 1. It is display 0 0 0 0 and 1 1 at output. So the code is working fine. Now let us move towards the task number 3. Task number 3. Now let us go towards the next task. So what we are doing next is display the changing sequence of LED on Nanopod simulate on Atmos Studio as well. So basically what we are doing, we are turning on the LEDs one by one. What we are making, it is a battery charging simulation in which one LED starts and it remains on, then another LED start and so on till the end, and then again start from zero. So now let us move towards the Proteus. This is the Proteus. Now let us add the code for Proteus. First of all, let us see the actual value as well. Now let us go to File, Open, Project Solution, Lab Task 3, Task 3. So this is the file. So basically we are declaring our port D as our output port and then displaying values one by one, making one LED high, and that at the end we are making all the pins 0, and then this is a loop for 1 second delay in using delay function by calculation, which will waste our cycles for that delay. So now let us simulate, add the file and then simulate. the file task 3. So this is the sequence for LED going from high to low, and then after that when it reaches it all clears and start from the start. Okay, this is a simulation. Now let us move towards the task 4. So basically what we have to do in task 4, free open the yeah, Atmel Studio, and let us until then see the task where we have to take two values from different ports, compare them. If both values are same, show this value, and if they are not, show this value. So basically when they are same, it will show us 12 12, which is 10 is A, 11 is B, and 12 is C, which is show us CC on third port, and they are not equal, then it will show us 3 3 on the other port. So this is the code that we are taking in for comparing and calling delay function. Now let us move towards the code main.asm file. So this is the code written. This is the upper part. The lower part is for delay. The upper part is for register, storing the value and comparing the register. We have used a command of brne branch not equal to 0. So let us move towards the Proteus. So upload the properties, upload the file, which is task number 4. So to task number 4 project. So as we can see, both of the values are same. No, so it should give us CC. So both of the values are same. It is giving us 1100 and 1100. So let us change one of the values. So after the updatation, it will give us, it has given us 3 3. So this is the simulation. Let us close. So let us move towards the final part. So what we have done, it is a simple implementation of all the commands of move, out, subtraction, inclusion, decrement, and complement. So basically what we are first of all storing the values, then moving the values using me function into another register, then we are uh, subtracting the two values and storing the answer into a register 18. Then what we are doing, we are outputting the value of register 18 on port B, then we are incrementing the value in register 19, and then we are decrementing the value in register 20. So as you can see clearly on the register using the IO monitor. This is the code. Now let us move towards the final part, which is the traffic light simulation. So in the traffic light simulation, what we have done, we have made a traffic light in which we have four traffic lights and they will move accordingly to the delay. Now let us move towards that. Upload the file. So this is the traffic light simulation. First of all, the right is green. Then after delay yellow, and then this will go green and this will go red, and the cycle continues on for these lights as well. So yellow, then it will go green and it will go red. So this is the traffic light simulation part. So now let us move towards the hardware videos and their implementation. Now let's go to the hardware videos and their implementation. First of all, we have task 1. This is the second video. This is the second hardware implementation video. Then we have the next video in which we are changing the values and it is updating itself. So this is from my side. Thank you for watching.